today's lecture, we are going to complete Lami's theorem topic. You must understand that in the previous lectures, we have discussed about Lami's theorem, the formula, the derivation of Lami's theorem, and then after we have solved lots of numericals regarding Lami's theorem. I am repeating again that in the Lami's theorem, 2, 3 or 4 things are most important. First one is that whenever the string is coming into the picture, then always tensile force is acting in the string, and tensile force is always towards the fixed point of the string. Okay, so this is the point number 1, which is must. Number 2, reaction of the contact point is always starts from the contact point and passes from the center of the sphere. Okay, reaction of the contact point always starts from the contact point and passes from the center of the sphere. Point number 3, whenever required, draw a dotted line at the concurrent point and then after find Z, so that you can find the angle very easily by alternate angle method, vertically opposite angle method, or by any other method. And the last point is trigonometry. So whenever required, you have to use tan theta, sin theta, cos theta, etc. by using trigonometry and tan inverse, cos inverse, sin inverse to find the required angles in your calci. Now, this is the example number 19 on your screen. Today, we will discuss 2 more numericals which are very important, which are out of the topic actually. So you just careful and see the figure very carefully. State Lami's theorem, determine the force P required to keep the system as shown in figure in equilibrium. So first of all, we have to determine Lami's theorem. As you know that, what is Lami's theorem? It is also written on the screen. If 3 coplanar forces acting at a point be in equilibrium, then each force is proportional to the sine of angle between the other two. Each force is proportional to the sine of angle between other 2 forces. So P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. We have already proved this equation in our earlier lectures. Now, according to the figure, we are required to find unknown force P. Now, concentrate on the figure very carefully. This is unknown force P, which is compressive at this point. And the other 2 forces, 60 Newton and 40 Newton, both are tensile as you can see. And these 2 forces are making angle 40 degree. These 2 forces are making angle 40 degree and alpha with vertical as shown in figure. So now, alpha is also unknown and P is also unknown. So we have to find P and alpha. How? Well, let us start with the Lami's theorem. Now what is given to you? First one is force P. So you can see here it is force P, second force is 40 and the third force is 60. Now main important thing is how to take angles actually. So you can see when you are taking force P, okay, then you have to take the angle between other 2 forces. So what is the angle between other 2 forces? You can see this force P is compressive, so it will be converted into tensile force like this. Then after, the opposite angle will be like this, the angle between other 2 forces. So this angle we have to calculate, which is equal to, straight line is of 180, so this total 180 and this alpha and this 40 will be subtracted from 180, so you will get this required angle, correct? So this required angle will be 180 minus 40 minus alpha. So here it is written at 180 minus alpha minus 40. So it is the opposite angle of force P, correct? Let us change the color. What is the opposite angle of force 40? So here it is force 40 you can see. Then the opposite angle means angle between other 2 forces, which is over here. This is 90 plus this is alpha. So 90 plus alpha is the opposite angle. So upon sine 90 plus alpha. the third force will be 60. So opposite angle of 60 will be 40 plus 90. So it is 130. So 60 upon sine 130 is the third term. Now we have to compare first and second, then after second and third, or second and third first. See, remember, here there are two unknowns. P is also unknown and alpha is also unknown. So first of all we have to calculate alpha. So we will compare second and third term to get the alpha, and after getting the alpha we will replace it into the first term. Let us see how. See, this is the simplified figure. You can visualize this is the force P, which is now tensile, and all the angles are shown to you. Let us compare second and third term. Must remember that sine 90 plus alpha will become cos alpha as per the unit circle, all STC. Sine 90 plus means second quadrant. So in the second quadrant, sine is always positive, and sine 90 plus alpha, which is equal to cos alpha. You must know this according to the mathematics. So the equation will become 40 upon cos alpha is equal to 60 upon 0.766. You just cross multiply and do the cos inverse of this term. You will get the answer of alpha is equal to 59.34 degree. Now this is the alpha, our first term. First answer actually. Now in the first term the denominator will be sine 180 minus alpha minus 40. So just replace this alpha over here. You will get sine 180 minus 59.34 minus 40. So it is sine 80.66. So now the value of first term will become P upon sine 80.66, and the second term is 60 upon sine 130 by replacing all the values. So just compare, cross multiply, and you will find the answer of P as 77.23 Newton. So once you are getting alpha, then the numerical is very easy for you. So you have to just prepare for the alpha by trigonometry, by any simplification method. Just simplify the figure very carefully. Okay, so you will get the alpha, and after getting the alpha, P will be very easily calculated. So this is the numerical number 1 for today. Let us see another numerical, in which what is the data? Example number 12. A body weighing 2000 Newton is suspended with a chain AB 2 meter long. You can see in the figure that this is the chain AB, which is 2 meter long, correct? And from point B, a body of weight 2000 Newton is suspended. This is the distance x, and the angle with horizontal is theta. The right side force acting on this is 320 Newton. So horizontal force of 320 Newton is pull force by which the chain is pulled. Find the force in the chain and the lateral displacement of the body. We have to find tensile force, means tension in the string or chain, which is going in the upward direction towards point A, as I said earlier. So this force will be denoted by F in this free body diagram. Horizontal force is like this, 320 Newton horizontal, and vertically downward force is 2000 Newton. The angle is theta over here. This angle will be 90. This angle is also 90. And remember that this angle will be 180 minus theta from the geometry of the figure. Total angle is 180. So this angle will be 180 minus theta. What is our question? First question is to find x, and the another question is to find this angle theta. Let us start now. By using Lami's theorem, you can see that F upon sine 90. Let us go back to the figure so that you can easily understand. See this, F upon angle will be 90. 320, if the force is 320, then the angle will be theta plus 90, 90 plus theta, correct? And if the force is 2000 Newton, then the angle will be 180 minus theta. So by applying Lami's theorem, you will get this equation, F upon sine 90 is equal to 2000 upon sine 180 minus theta is equal to 320 upon sine 90 plus theta. So now F upon 1 is equal to, now sine 180 minus theta is equal to sine theta from all STC. Sine 180, so function will remain as it is, and sine 90 plus theta is equal to cos theta, as I have discussed earlier. So now the simplification will become F upon 1 is equal to 2000 upon sine theta is equal to 320 upon cos theta. You just compare first and second term, then you will get the answer of F sine theta is equal to 2000, And if you compare first with third, then you will get f cos theta equal to 320. So this is equation number 1, you can say, and this is equation number 2, you can say. So just divide equation 1 by equation 2. So you will get f sin theta upon f cos theta is equal to 2000 upon 320. So answer will be f cancelled out, and sin upon cos theta is equal to tan theta is equal to 6.25. So theta will equal to tan inverse 6.25, which is equal to 80.91. Now just replace this theta in equation number 1 or 2. By replacing in equation number 1, you will get f sin theta is equal to 2000. So f sin 80.91 equal to 2000. So now f equal to 2025.43 Newton. It is very easy numerical. But now from the figure we have to calculate x also. For that x we just have to use trigonometry. Let us go back to figure. You can see this. What is this? You can see this is the right angled triangle. Right angled triangle. In this angle is theta. So what is cos theta? Cos theta equal to adjacent upon hypotenuse. So here adjacent side of the theta will be x, which we have to find. Adjacent side is theta, and hypotenuse will be 2. Correct? So now we have to find cos theta. So cos theta is equal to x by 2, adjacent upon hypotenuse. So let us solve. Cos theta is equal to x by 2, in which theta equal to 80.91 and x by 2 will remain as it is. So by cross multiplication, simply you will get from the calci that x equal to 0.316 meter. So it is the horizontal distance which is travelled by point B by applying horizontal force at point B. So these are two separate numericals which are out of the topic, which are some logical numericals. So you just practice these numericals, and here we are completing our topic Lami's theorem. By revising lecture number 1 to 9, you will just complete the chapter actually. Okay, in the next lecture, means in lecture number 10, I will just discuss 2 or 3 small theories. After the lecture number 10, our first chapter, means coplanar concurrent forces, is going to complete. So next lecture will be our last lecture, in which this chapter is going to be completed. So now we are completing this lecture as of now. Till then, revise this lecture. We will meet in lecture number 10. Then we will discuss 3 theories and complete the chapters. Okay, so goodbye students. Thank you very much.